So this is cellular respiration. It's really the whole thing. That's what you need to know. There's another part called fermentation, which isn't a part of cellular respiration. When we talk about cellular respiration, we're referring the part where oxygen is needed, the aerobic portion. But there is a portion where you can actually get converted to lactic acid and stuff, which I'm going to show you. So step by step, all right, try to ignore all that until I get to that. So the first part is, this is the cytoplasm, and over here is the mitochondria. We're going to talk about different parts of mitochondria, because different parts of mitochondria have different processes going in. I kind of showed you the anatomy where there's two membranes in there, and spaces and stuff. So first thing is that we're going to use glucose, which is a 6-carbon molecule. That's going to be converted to pyruvic acid, also known as pyruvate. For your purposes, it's the same thing as pyruvate. That's a 3-carbon atom. It's a 3-carbon structure. But we're making 2 of those, right? Take 6 divided by 2. They were trying to bring in something you learned from 3rd grade. All right, big plus. All right. So we're going to go from glucose to pyruvic acid. The reason why we're doing that is because we can't get the glucose into the mitochondria to make energy. Yes. Yeah, because there's 3. If this is 6, then it's going to be 3 times 2, right? So that's. Does that make sense? Okay. So yeah, or you could write it like 3C and 3C. It'd be 2 words, too much for the core. So we have to get this big molecule into there, but it's too big to get through there. So in order to do this, to break it up, we're going to have to use 2 ATP, an investment, 2 ATP to break that up into 2 smaller sections. But in the process, keep in mind, this is about 10 different reactions over here. I've simplified it for you. But in the process, 2 ATP go in, but 4 ATP go out. So in this process, we actually gain 2 ATPs. Okay? In addition, we are also going to reduce NAD+. Actually, 2 of them. They become NADH. And we can use this later on to convert into energy, ATP, which we're going to show later. This process is anaerobic, doesn't use oxygen, and it's called glycolysis. Glyco meaning glucose, lysis to break up. You're going to see a lot of these words popping up, but it makes sense if you break up the words. Okay? So you have this glucose turning to pyruvic acid. Now the pyruvic acid is small enough to get into the mitochondria. If there's oxygen. No oxygen, it's going to go through fermentation, which we're going to talk about. It's not drawn here. Now the pyruvic acid goes into the mitochondria with oxygen. Now making your life easier, because you've got to count where all these C's are going, I'm only going to be talking about 1 pyruvic acid entering here. So we're just talking about 1 free C. But there's 2 of them for 1 molecule of glucose. Does that make sense? All right, it's just easier to follow 1 3-carbon skeleton than to worry about 2 of them. You'll figure out all of this and then just multiply by 2. So if I say how many ATPs are made with 1 molecule of glucose, then it's this times 2. If I say how many ATPs are made with 1 molecule of pyruvic acid, then you won't times it by 2. You've got to keep track of them. Does that make sense? So to make our lives easier, I'm only going to talk about 1 molecule of pyruvic acid going in here. Is that clear? That's fair, right? I think most teachers do it that way. Okay? And your book will say that too. All right, so pyruvic acid gets into the mitochondria with oxygen. The oxygen is going to be used to combine with one of the carbons of the three-carbon skeleton and go up as carbon dioxide, leaving a coenzyme, coacid, what is it called? Coenzyme A is going to be added here, and you're going to make an acetyl-CoA. Okay? There's steps in here. We're making it easier for you to understand. Okay? So now you've got this acetyl-CoA that's only 2 carbons. The one carbon came off with carbon dioxide. So now we've got 2 carbons with from one pyruvic acid, right? Now this 2-carbon structure can enter something called the citric acid cycle, also referred to as Krebs cycle. TCA, the citric acid cycle. Okay? That goes in here as a 2-carbon structure. But we also have something called oxaloacetate, which is a 4-carbon structure. You combine the two, and you got yourself a 6-carbon structure, but it's formed differently. It doesn't look like glucose. It's called citric acid, or citrate. All right? Same stuff that's in orange juice. Okay? It does this big cycle. There's about 8 different steps in there. There's 8 different enzymes. You do not have to worry about them. What you do have to worry about is what goes into it, as I just showed you here, and what comes out of it. What comes out of it is 2 carbon dioxides. For 1 molecule of pyruvic acid, you get 2 carbon dioxides, and we get 1 over here. That's all the carbon dioxide that's going to be, you're going to be blowing off. That's where it's coming from. You'll also produce 1 GTP, guanosine triphosphate. For our purposes, it's basically the same energy that comes out for ATP. So the GTP and ATP are basically the same. Okay? Questions? You will also put out these things. You'll get 3 NADHs that come out of here and 1 FADH2. These are powerful things that can be transformed into ATP. We also, as I mentioned, there's also in this process where the preparation of becoming acetyl-CoA, you also created another ADP or ADH over here. So we have 2 NADHs here, 1 ADH here, 3 ADH over here, 1 FADH2 over here. All of those, and that one over there can come into the mitochondria if it wants. They will all pour into this electron transport chain. And in this process, you're going to convert those electron carrier protein or electron carrier molecules and turn them into ATP. In this electron transport chain, ADP with an inorganic phosphate turns into ATP. For every NADH you have, you get 3 ATPs. For every FADH2, you get 2 ATPs. Okay? This is where we need oxygen. Remember how we have the two ingredients to make ATP? Glucose and oxygen. This is where the oxygen really takes part. A little bit of oxygen happening over here, but this is where it really takes up its job. And that will turn into water. All right? So you're putting in, look what's happening here. You're taking glucose and oxygen, and what are you going to put out? The stuff in green. CO2, and water. And the big thing is ATP. The only other thing I want to mention is about fats that you're eating, your Snickers bar and stuff. You can get energy from them, because there's loads of energy. What it comes down to is that you're basically triglycerides. And triglycerides are made up of a glycerol molecule and 3 long chains of fatty acids. The fatty acids are usually in pairs of 2. So they're either 14 Cs long or 30 Cs long, that kind of thing. I've never seen them like 25 or 19. So what happens here is that we can use this for energy. So you have triglycerides, which is that big thing, made up of a glycerol molecule and 3 fatty acids. The glycerol gets broken off and can go in, we have enzymes that can actually turn it into glucose. So that feeds into the whole energy thing. We can take the 3 chains of fatty acids, break them off by 2s, and go into a process called beta oxidation, which occurs in a mitochondria. I'm sorry it's shown over here, but I put the star here because it's up here. And the beta oxidation takes every 2 carbons, makes them go through a series of reactions. You've got to put ATP into it, but you're going to spit out a lot of FADH2 and NADHs. This fatty acid, these 2 carbons, will turn into acetyl-CoA, which is 2 carbons. And that'll feed into here, let alone you have more energy that can be fed into the electron transport chain. And that's it. Simple. We clear with that? All right? It's recorded, so you can watch it. All right? But it's better when I have it step by step by step. So you understand, in the cytoplasm, it's anaerobic, it does not use oxygen. Or in the mitochondria, it's aerobic, it uses oxygen. That's a key point. Like I said, what you got to get out of this, ready for the test, you need to know what goes into each process, what comes out of each process, where the processes take place, all right? And what's the significance of each process? 4 things you really need to know. The steps, I'm kind of like making that like not so much.